Today we'll discuss dedicated models for quick reads in your product. Hi, Tomek.
Hi, Łukasz. Yeah, I think we also wanted to, let's say, some kind of close the topics for the all building blocks that we can have, like in our application when we say about the event-driven architecture, right? Because right on we had like aggregates before, but we could not get the state of them, right? Because they have like all the state is encapsulated inside the aggregates. So I think we can jump into the code, right? Directly.
Yes, let's jump to the code. And just to make it clear, this will be one of at least 2 episodes on that, because today we'll discuss synchronous read models. So they will be executed right after the aggregate changes its state. In the next episode, we will discuss asynchronous read models, which will be eventually consistent. But we'll get into that buzzwords probably next week. All right, let's jump to the code.
Yeah, so if you recall, we have this task model, which is an aggregate in our case. And we have some kind of methods for that model there where we apply some events. And you can see that in the private section, we have those name, date, status, and ID. So basically, when you have an application, you would not be able to see those tasks, right? You will not be able to display them anywhere because they have like internal state closed inside the aggregate, right? Even though you can like call all those methods, you can also get the current state of the aggregate, but you don't have the like access to the internal state. So so the answer for that, how we are able to like see anything on the UI, we should have some kind of read model, right? So separate model, which we use only for the read purposes, and we have the all data that we need on a specific, like, I don't know, even piece of the page, right?
So let's see the model.
Yeah, so we created like simple active record model here.
Yeah, it's not much.
It's not much
supposed to be complex.
Exactly, because it's like it should be like flat structure just to get like the information that you need, right? And you have like name, due date, status here as well. And then what we do, actually, we subscribe to different events that are published when we change our aggregate. And we have the builder, which based on the event change name of the read model, actually, right?
Yeah, it modifies the active record in the database. So so we have 2 things. We have one model that is specified and that has the job of writing to the event store, and then based on that outcome, so the outcome will be event in that case, as the model is event driven. We have the subscriber that is interested in that event, and then it creates and updates the other model, which is the read model. And just to remind you, the events are stored in the depends on your configuration. In our case, it's in the JSON table. It's in the event store events table, in the JSON column, sorry. And the read model is just regular relational model that is maintained by, and you can just work with it through the active record, as you can see in the task view model.
Yeah, and I think we also should mention here that last time, like we were showing you how to expose the state of the internal state of not expose the internal state of aggregate, but also to build some kind of views using projections, right? But the projections, they are like we are applying events in memory, let's say, right? We do it on the fly, but the read models themselves, they are like better when you have to have those data stored and accessed quickly, right, on the database. You are like you don't want to build projection every time. You can actually use the projection to build read models, because sometimes they can be like there could be this kind of like inconsistency, right, between the write part, write model, which is the aggregate, and the read model, because we by default we treat read models as something that is should be like it's not a source of truth, right?
Yeah, you can dispose it and recreate it from scratch.
Exactly, and for the recreation from scratch, you can use projections, right?
And the reason for that is that the truth lays in the event store, right? So for the task, which is event sourced, if someone asks us, where should I look if something goes off? The answer is you can safely remove the read model. In this case, this is the task view model. You can just call delete all and then rebuild the read model from events. And you can always do that. So even if you make some mistake, you can just rebuild the read model. And of course, it's not always that easy. It's not always super quick, but that's the topic for another video.
Yep. Yeah, so I think from the code, let's say, point of view, we are done here, right? We can do some demo, maybe.
Just maybe to comment one simple mechanic. As you can see here, if we already have task created, and for example, the task name is changed, so the event type is task name changed, we'll go into this change task method. And then what change task method does, it searches the task view model based on the ID, and then fetches the name, the new task name from the event, sets it, and then saves the model. And that's basically it. It doesn't check if the name is correct or incorrect because it doesn't care. The event is a fact. It already happened in the system, so the read model doesn't interpret it. It just applies it to its internal state. And then later on, it will be displayed in the UI or in the console, like in our case.
Yep. So in the console, we have like this task service, and we want to create new task, right? Create task, if I recall correctly. Yeah. So you can see here that we like there was a new event, and we also synchronously, because this episode is about synchronous read models, we like inserted to the task view model some data. So in the browser, you can see that indeed there was task created event, and also we have task view model. Okay, maybe all, right? Because we.
That's just one, yeah.
Yeah, and you can see that this UUID is like this one that is in the view model as well.
Yeah, and we just created it, so the status according to the the write model is open by default. So that's what we inserted in here. Now, if Tomek would rename the task, so we call change name, and now we need the task ID.
Task ID first, right?
Yeah,
okay.
This one. Yeah, and then second argument, some name.
Creative name. Yeah.
Very creative. So now what you can see is that besides the insert of event and insert of the streams, we also have the update query that updates the name of the read model to the value that Tomek specified, which is the new name. And now if we just, we can see the event as well.
In the browser, in the browser you can see that there was the new event, and task view model is like still it's just one task, right? But we have the name. So the source of truth is like with events. So we have two events that two things happened, but here we just update one model, right?
Exactly. Now, if you would have, I'm not sure if you can see what I'm typing, but we'll see that in just a moment. So if you had the URL that would show /task/ID, for example, then, whoops, it disappeared. But you get where I'm going with this. You could just view this task, and it would be Would it be much more quicker than just loading it from projection? Probably if we know the ID and just load one, like all the events for one task, it wouldn't be slow. But if we think of some tables or showing the Kanban table for all the tasks, this way it will be much quicker, because as you can see, the query is very simple. It's just the select.
Yeah. Yeah, just in topic of the synchronous read models, I think it's like we thought that it will be easier to show that first, because I think it's like if you don't work with read models and like asynchronous handling of events, it's like it will be easier to introduce to your application, right? Because you don't have to change your UI when you publish the event. You don't have to do any optimistic UI, right? There, everything
you don't have to do sophisticated techniques to show to keep the same behavior that you have. With async, it's a little bit more complex. Not in every case, but sometimes you need something that Tomek mentioned, optimistic UI. That, for example, one of the methods is just kind of lying to the user that what they want, what they requested, succeeded. yeah, it's like we consider that the operation, we assume that the operation will be successful. So without even waiting for the read model to be updated, we can show this information. If something goes off, we can, for example, show the notification. Okay.
Eventually, it will be consistent, right?
Yeah, eventually it should be consistent. But there was still, even though the sync read models are basically just sync handlers are much simpler, there are still some decisions that you have to make. Because if you could go back to the code, Tomek, for example, in a case in which the task view model builder, if it would throw an exception, for example, when we try to create task or change the name, doesn't matter. Okay, so if we, for example, simulate that something goes off in here, and now if we need to reload the code exactly, and if we try to create a new task, this will be interesting. Remember that we published 2 events, so there are 2 events in the event store. And now there will be third event.
Yeah, just okay.
Let's confirm. Okay,
yeah,
my math is okay still.
So there are
still
2 events now. And now we can create, right?
Yeah, let's create one. All right. So we can see what happened here is that we open the transaction to insert the event and to insert the event's streams to kind of create this mapping to which streams the event belongs. But then we see that the read model wasn't executed, obviously, because we raised an error here. But now we have some kind of inconsistent state, right? We have the source of truth here, which is that we know that the task was created. But if we go to the read model, to the console right now and ask for all the task view models, you can see that it's still not here. So if you just go with the setup that we have on this video, so if you subscribe the sync read model builder to the events, this will be your default behavior, but we can change it, right? We can change it. So to change it, in our setup, what we need to do, we can keep this exception for now. And if we could go to the task service, and what is important for you to know that in this code, for example, all the sync handlers in the default setup are executed in this store method. Actually, it's not in the store method itself, but when you look at if you look in the internals, you can find it. Actually, it doesn't matter that much. It's just important to know that whenever you store your events with aggregate root repository or you publish the events, these handlers are going to be run right after. So they should be run somewhere here in this code in between line 8 and 9 inside of this store method. You can read more about this behavior in the documentation. But if you would like to change the behavior, we can open a transaction. And if we do open another database transaction, we'll have 2 of them, nested transactions, right? And in case of the Rails version we're working with, which is Rails 7, this code will behave differently because now the read model will be executed together with the write model. So we'll insert both the events and try to insert the read model. And as you can see, this affects in rolling back the transaction, which leads to the fact that, well, we don't have this event in the event store. So there still should be 3 events instead of 4 as in previous behavior. So keep this in mind whenever you design your code. This is the decision that you have to make. And in case that something goes off, in this case at least, if the user repeats the information, the operation, it will be easier for you to handle because you will not have, for example, 2 events, so 2 new tasks created in this case. If you go with the previous approach, well, you may not display the task, but you'll still have 2 of them created, right? So you have to make your choices and then handle the situations in which something goes off in one way or another.
Yeah. Only thing I would like to add, I mean, in my humble opinion, it's like, I think we also discussed that before. It's like, in this case, you couple 2 things that, I mean, in my opinion, they should not be coupled, right? You are coupling something that happened. So when you're using the write model here, and you know that something happened, right? So you are trying to publish the event, but then you have some kind of like synchronous subscriber that actually can, like, always something can go wrong there, and it will also affect something that actually happened, right? So you are like doing some kind of rollback of something that would normally would go fine, right? Yeah, and in this case, actually, you have the source of truth, so you know that something happened, so you can recreate read model. You have the inconsistency, but you can still recreate the read model. But here, let's say your handler affects also the, let's say, business logic in some way, let's say, right? That's why in the next episode we also would like to show you like asynchronous read models, right?
Yes, that will be the next episode. Yes, and I think that's it for today. So thank you for watching. If you have any comments or questions regarding read models, please add the comment below. We always answer to all the comments because there's not so many of them. And see you next time.
See ya. Bye.